then I don't know what the percentage is, but I'm going to find it. And they want to know who spend less than. So that means X is supposed to be less than 1,160. So if I try to put this, just because I like to go along with my curves, my mean is no longer 0 in the middle. I'm now centered at the 1,228. And then I want to be less than 1,160. So at that point or below. That's what I want to be able to find. So we can do that by saying, all right, let's create a z-score and figure out where we are. So I've got 1,160 minus my mean of 1,228 and divide it by the standard deviation, 229.44. And let's see what that gives us. 0.33? That's his final answer. I need the, do you have the z-score? 296. All right. Does everyone agree? Okay, now remember, your z-table only allows you to have 2 decimals. So let's round it to 2 decimals, which bumps this to a 30 when you round. So I would go look up negative 0.30 on my table, the negative table. So negative 0.3 and 0 is that very first column. So if you want to bind your pieces. So that tells me that I'm at, it's hard to see on there, but 0.3821. So let's take that back. From the table, we get 0.3821. So that means the probability a woman spends less than 1,160 at Christmas is 38.21%. It's pretty low. Does that surprise us? Yeah. So you're going to go back to the negative table. And we know the first 2 digits tell us what row, right? So we've got negative 0.3. So go to the row with 0.3. And then your last digit is a 0. So I'm going to come up to where I've got a 0 in that second position and figure out where they cross. But back to my question. Does it surprise you that that percentage is low?
Yes.
Really?
Maybe in San Diego.
I don't know many women that only spend 1,160 at Christmas. The probability of them spending less than that amount. 38%. 38%.
That means that how much of them are spending less.
I'm
not surprised by the number.
Oh, okay. I thought you were saying you were surprised by it.
No.
All right. You know, we shouldn't be too surprised because generally you spend a lot more at Christmas. All right. So, questions on the formula and the table? No, we can use the calculator. We're getting to that next. I want to make sure we're okay with this form. All right, so before we used normal CDF, and it wanted, same thing, wanted a lower and an upper. So the lowest we want to be is, well, like we'll say negative infinity, but we can't go below 0. But we can put negative infinity. And the highest we want them to spend is 160. Now this is a non-standard normal, so I need to put in the given mean and standard deviation rather than 0 and 1. So my new mean is 1,228, and my standard deviation is 229.44. And then it's going to calculate that probability for me. So let's go to our distributions and go to the normal CDF. And let's put in negative infinity, so it knows that we're not stopping on the negative end. But we only want to go up to 1,160. With a mean of 1,228 and a standard deviation of 229.44. Everybody get it sort of filled into that answer? What? The lower is your negative infinity. So you'll put in the negative e to the 99. Yes. The e is just telling it that you're going to have a really large negative number. If you're doing a left tail or a right tail. So then you'd have your number in the lower and you'd have the e part in the upper part. So they switch positions. No, it should be a positive one. That'd be the upper. If you're looking for the area in between, then you've actually got the two numbers for the lower and the upper. All right, if we calculate that, we're pretty close. We're not going to be exact. Why do you think that is? The table's limited. This has a lot more decimals that it can keep. So it's going to be slightly different. I'll take both answers though. So it doesn't matter. So if I was to take this and round to 4 decimals like we have on the table, we've got 0.3835. And then you would tell me the same thing. The probability a woman spends less than that amount is 38.35%. So you can do it that way as well. Each month, an American household generates an average of 28 pounds of newspaper for garbage or recycle. Assume the standard deviation is 2 pounds. If a household is selected at random, find the probability of it generating between 27 and 31 pounds per month, and then more than 30.2 pounds a month. And we're assuming that it's normally distributed. All right, so again, the first thing I did was read because that's the most important. Then I need to identify. What can I identify in here? The mean. What's the mean? What's the standard deviation? All right, now if we look at A, those two numbers stay the same for both. For part A, 27 and 31 are what? The upper and lower. So x for the lower is the 27, x for the upper is 31. So if we actually drew that out, we would get 27 with our mean of 28 and 31. And you want to know about being in between them. So I've got my lower and my upper already, and we can use a normal CDF where we go from 27 to 31 with a mean of 28 and a standard deviation of 2. And let's see what that's going to give us. So find my normal CDF. Lower's 27, upper's 31. My mean is 28, and my standard deviation is 2. And we'll hit enter. Does everyone agree? So 0.6247. So what would you tell me about that? Good. So the probability of a household generating between 27 and 31 pounds of newspaper waste per month is 62.47%. Questions on that? Yes. You will never use the PDF. So for normal, always use a CDF. All right, for the next one, we want to be above 30.2. So I've got my 28 in the middle, and I want to know about 30.2 or more. So what do you think I'm going to enter here?
That'll be your number. 30.2 would be your number.
30.2 is the lowest I want to be, so 30.2.
And then the infinity.
Then infinity in the upper, so E99 in that upper portion with the same mean and the same standard deviation. Because it's the word more, yep. So if we go back, pick the normal CDF, the lowest is 30.2. The upper, I'm going to do second with the comma button to get my E and the 99. And I don't need the negative this time. And then 28 and 2, and hit enter. So that is 0.1357.
I got the same thing, but I put a 1 instead of the E.
That's fine, it should be the same thing. So for this one, the probability a household generates more than 30.2 pounds of newspaper waste is 13.57%.